Hi everyone, welcome back. And today's topic is induction type relay, induction disk type relay. So normally an induction type relay there are two classification. One is induction disk type and another one is induction cup type relay. So here the shaded pole induction disk relay, the shaded pole induction disk type relay. So here the rotating disk is made up of aluminium. So that why the rotating disk is made up of aluminium is because of less weight. So that only it is made up of aluminium. So better we can choose plastic instead of aluminium. No, because the aluminium it carries the flux. So here in the aluminium it induces the EMF. So only there is a tendency to create the force for the movement of aluminium disc. So in the shaded pole type construction, a she-shaded electromagnet is used during the construction. So one half of the each pole of the electromagnet is surrounded by a copper band, which is the unshaded ring. The shaded portion of the pole it produces a flux, which is displaced in the phase as well as the time. So in order to with respect to the flux produced by the unshaded portion of the pole. So here the two alternating fluxes which is displaced in the phase and time and so that cut the disk and produce eddy current in it. So because of the produced eddy current, the torque are produced by the interaction of each fluxes with the eddy current and produce the other flux. So the resultant torque it causes the disk to rotate. So there is a two schematic diagram. One is a simple construction. Another one is the construction in the practice, in the practical manner. Okay. So in this construction, both are same. The only thing here, the shaded pole, one thing is different. The another everything is same. So here we are supplying the current to the coil. Here we are supplying the current to the coil. The current is taken from the current transformer of the line. Okay, so here there is a plug setting is connected. So what is the use of plug setting? Suppose if the secondary of current transformer is taken as 10 amps, but we can able to change the pickup current is 2 amps. Okay, 2 amps. So here we have to use the plug setting multiplier. Okay, so for example, if you need the operating current is 10, so the 5 is multiplied with 2 in order to get 10 amps. If the operating current is 20 amps, so 5 into 4. So the plug setting multiplier is 4. Now the 5 amps is converted into 1 amps. So the plug setting multiplier is 1 by 5. So 5 divided by 5 is our getting 1. So the plug setting multiplier is to adjust the pickup current to adjust the operating current so that the percentage with respect to the 10%, 20% and 100%, 200% we can able to vary the operating current with the help of plug setting multiplier. Okay, so here the current is which we are taken from the current transformer. So during the supply of current, the coil is getting energization and it produces electromagnetic flux. So the produced electromagnetic flux will be circulated through the shaded pole and unshaded pole. So there is a flux difference between shaded pole and unshaded pole. So the flux which are interacted by the unshaded and the flux which is interacted by the unshaded on the aluminium disc. So the two fluxes are interacted in the same aluminium disc. So with the phase displacement with respect to the displacement angle, so there is a force the aluminium disc gets rotated. So if the aluminium disc gets rotated, so there is an trip circuit. There is a fixed contact and moving contact. The both contacts gets touched so that it gives the tripping mechanism to the circuit breaker to isolate the faulty section. And this is the shaded pole. Okay, and the second one, wattmetric type. So here, which is similar to the energy meter, which is similar to the permanent magnet moving coil, both the moving coil type. So in wattmetric type construction, two electromagnets are used. One is upper electromagnet, another one is lower electromagnet. So the each magnet it produces an alternating flux. So the produced flux will be cutted by the aluminium disc. So to obtain the phase displacement between the two fluxes, the upper and the lower electromagnet coils may be energized by two different sources, or we may connect some inductance and capacitance across the inductance in the coil, both in the upper and the electromagnet. If they are energized by the same source, the resistance and the reactance of the two circuits are made different so that there will be a sufficient phase difference between the two fluxes. So the induction disc type construction is robust and construction. So this is a schematic diagram. So this is an upper electromagnet and this is the lower electromagnet. So the upper electromagnet is energized by the current from the current transformer, and the both upper electromagnet and lower electromagnet is getting interconnected. So because of the current received from the current transformer, it produces flux. The produced flux, it will be interacted with the secondary coil. So there is an induced EMF in the secondary coil. Because of the induced EMF, there is a current flow through this coil. So because of this current flow, here also a flux is produced. So from the upper electromagnet, we are producing some amount of flux, and from the lower electromagnet also we are producing some amount of flux. The two fluxes are interacting in the aluminum disc. So the aluminum disc gets rotated, so that the two contact will be gets touching, so that we can able to isolate the faulty section. And this is an assessment. So what is the primary advantage of using the solid state relay compared to electromechanical relay for protection applications? Fast operation time, high current capacity, carrying capacity, lower maintenance requirement, and all of the above. So put your answer in the comment section. And these are the few textbooks. Thank you.